So as we know, here we are applying deep learning for rare event prediction. One of the objectives in rare event prediction was to do what we call as early prediction. If you remember, what early prediction basically means is predicting the event before it happens, because for rare event prediction such as a disease or a stock market crash, it makes little sense to predict it when it has already happened. You want to predict it before it has happened. And since this is applicable on most problems, we are dealing with this here. So the way or the challenge with early prediction is, suppose the event, and it will be a dramatic event, let's say this is some event, stock crash or something like that, happened at this point, the signal, the predictive signal for this event will be strong just before it and weak as we go further down in time. This is time. And the purpose is to predict it somewhere here early enough so that we can prevent or minimize the impact of this event. Now, from data point of view, how will our data look like for such a problem? Suppose I have my y denoting as my response variable, the labels. The y will be equal to 0, 0, 0 in most of this until here when the event has happened. So this will be my input data, the data given to me, label 1 when the event has happened, but I want to be able to predict this somewhere here. To do this easily, there are different ways to build a model that can do such an early prediction of an event, but one of the simplest way I find is by doing what we call as curve shifting. By curve shifting, what I mean is, there are different ways to interpret it. One way to interpret this is, I will shift my curve, my y, from here to here. Let's say I am shifting it by k time units. Suppose k time unit is 2. What I will do is shift this by 2, slide it here. And when I slide it here, what I'm going to do is, I'm going to replace these zeros with 1. And everything else remains the same. So this is shifted y. When I shift the y like this, for the model, it will know that these observations, these samples are labeled as my positive sample, or the positive sample, and therefore the model will learn to predict these instances. Another way to look at this is, which I find more intuitive, is we are more interested in predicting these transient states. The assumption is, before the event happens, there will be a transient state that leads up to that event. In this transient state, which lies somewhere here, this is my transient state, this part, where things start to shake up slowly, ultimately leading up to this event. If we just predict this transient state, that means we are predicting this event in advance. So if we just convert our problem by, instead of looking for this label, this positive label sample, if instead we are looking for this transient state, we build a model that is predicting this transient state, eventually we are predicting this event ahead in time. Programmatically, the way we have implemented it here is it does few steps. In step 1, it takes an input k, basically how much we want to shift it by. In the codes, it is using this parameter shift by, and when shift by is -2, it means we have to slide it by 2 time units, which basically means find the sample which is positive labeled, which is this. Take the 2 samples prior to that, which are these. Label them as 1 from 0 to 1, which I already did. And then delete this one. Drop this row. Why I'm dropping this row? Because in the data, this sample will have the strongest signal for predicting this event. If we keep these samples, the model will tend to learn more from these samples and might mask the effect of these transient states, which will subdue whatever I could learn from here and will majorly learn from these samples, but whatever I learn from these samples may not be of great value, because then I'm learning to predict the event when it has already happened, and which is not the objective. Therefore, to address that, I'm just dropping this original positive labeled sample. The code is still provided in the appendix. The requirements might differ from problem to problem, so feel free to customize the curve shifting definition that is provided to you that best suits your problem.